Professor Mary Chan, a scientist from Nanyang Technological University in Singapore. Good morning, Professor.
Morning, Professor.
Hi, good morning.
Thank you so much for joining us this morning on the C Morning Show. So what is this secret and amazing and miraculous material that you and your team are using, Professor Chan?
So we use this Zion. Zion is a protein obtained from the corn gluten meal. The corn gluten meal is a byproduct of using corn. So people use corn for fermentation now. And from the fermentation, they produce bioethanol. But the byproduct, the leftover, is called the corn gluten meal. And from the corn gluten meal, we can extract the protein Zion. So the main ingredient of our plastic packaging is Zion. And it also has other side ingredients like starch and cellulose nanocrystals. So those are the biodegradable base of our packaging material. And then we have also the active ingredients, the antimicrobial ingredients, mostly made from oil, like thyme, a common herb used in cooking, and citric acid, which is also commonly found in citrus fruits. So those are the main ingredients of our new packaging material.
Okay, now Professor, you mentioned antimicrobial. We've mentioned as well that this can help kill bacteria. What bacteria are we talking about here, Professor?
So we use the model bacteria E. coli. So E. coli is a common pathogen in food. And another bacteria that we work on is Listeria. So those are the typical different kinds of bacteria. So in bacteria, we have like a gram-positive and a gram-negative. So these represent the two different kinds of bacteria. We also work on fungi in this project. We work on the asparagus. So those are the pathogens that this formulation can eradicate. Yeah.
So this is bacteria that is formed on our food, basically.
So these bacteria could come from the fruits and vegetables. So in this project, we work on the fruits and vegetables. So in the farm, because of the soil and the handling, the bacteria can come from the soil or the handling, or it can come from the environment when it's already in the package form, like even from maybe refrigerator, if it stays around for a long time.
Okay, so you can essentially keep our food fresher as well then.
Yeah.
Oh, nice.
So how durable is this Zion packaging, Professor Chan? Because when it comes to more eco-friendly packaging in Indonesia, so far I think we have, the most famous one is a plastic bag made from cassava.
Correct.
So that it's degradable or it's biodegradable. So how durable is the Zion food packaging that you and your team have invented?
So it's pretty durable. We haven't really tested the durability. You will need more long-term study.
Yes? Yes, Professor?
So we are still in the process of testing the multiple use of it. So we envisage that such kind of packaging could be used for multiple times.
Okay.
Because our antimicrobial ingredients are so-called smart release. So the ingredients would only be released when there is bacteria or high humidity in the surrounding. So we have developed a kind of smart packaging because the packaging do not release these active ingredients until there are some harmful trigger, right?
Oh, wow.
The harmful trigger could be the bacteria or because of very excessive humidity. So in terms of durability, so we have issues like how long they can be used for,
Right.
and also the mechanical integrity.
Okay. Well, Marissa mentioned, was it cassava?
Cassava plastic bags.
Plastic bags that are actually not plastic, it's cassava.
Yeah.
I also think back to straws that are the paper straws.
Paper
I believe they're
straws,
cardboard. Now, they're great, but the problem that I run into all the time is when it encounters liquids, especially straws.
Yeah.
Like I'm in a rush to finish my drink because I know this straw is eventually going to go floppy. And I had a cassava bag that I kind of leaked some liquids, and it eventually kind of went it almost kind of leaked itself because it started to disintegrate. So how would this packaging hold up with liquids? Because obviously liquids or soups are some of the foods that we like to use plastic packaging for as well.
Right. So the one that we recently report, they are not so great for liquids, like what you say.
Right.
So this is a general problem for biodegradable polymer. But we are also developing the next generation of biodegradable packaging. So there are biodegradable packaging out there that could be used for our active ingredient.
Okay.
Just that they usually are more expensive and they may also have not so superior mechanical properties, like you want them to be very strong, stretchable, and all that. So yes, you're right in the sense that we need to find a compromise between the properties and the biodegradability as well as the properties. So we are still working on a future generation that you will have much better properties other than the antimicrobial properties.
Okay, that's good because I don't need it to last forever. I just need it to last through the day until I can consume it.
That's correct. And there are some.
I think it will last for a few days.
For a few days. Oh, that's good to know, Professor. The thing about plastic packaging, sometimes there are a kind of plastic packaging that can be microwavable. So what about the Zion food packaging? Is it microwavable?
It is microwavable, but not in the presence of liquids, I think.
Okay.
So when there's a liquid, we don't advise it to be microwave. But in general, we design this packaging not for the fruits because actually the fruits like a soup and all that, they have a different requirement compared to the vegetables and the fruits. So in this project, we are more targeting for the vegetables and fruits because this class of food, they actually would respire. So actually they will breathe and they will produce a lot of moisture. And so they have different requirements in the sense that you actually want the plastic packaging to be air permeable. You want the air and oxygen and water vapor to go through. So they are not having the same requirement as the common soup. The soup would need something that is impermeable. So different kinds of food actually would need different kinds of requirement as to the ability they can withstand the transmission of the oxygen and water vapor.
Okay. You mentioned a biopolymer, Professor. What is biopolymer and what does it do?
So a biopolymer, actually I think is the short form of biodegradable polymer. Okay. So generally there are several kinds of biodegradable polymer. Like polyester, some polyester, like polycaprolactone, polylactic acid. Like, for example, if somebody were to go to a hospital for a surgery, right? So you have a surgery, and you want the thread to stay there and then degrade away.
Right.
So those are the biodegradable polymer. You don't want to go to have a surgery and then have to go back and remove
get the stitches out. Right.
Surgeons. So that's the same concept as a biopolymer, that you want the polymer after you use it and then you toss it away in the soil and then it will decompose.
So this has been
that
around.
will prevent a lot of
Yeah. Okay. This has been around for quite some time then, because I remember years and years ago I had two types of stitches. I had internal stitches and external stitches, and they said you only have to come back to get the external stitches out. I'm like, what happened to the ones on the inside? They're like, oh, they'll just kind of disappear.
They'll just disintegrate and be part of your body, and it'll be fine.
It's amazing. That's what we want our packaging to do.
All right. Well, when do you think the Zion food packaging going to be widely available, Professor Chan? Maybe not only in Singapore. I mean, in Indonesia, we will definitely welcome such invention. Yeah.
Yeah. So we have received a lot of interest, and we are working hard on it to scale up the process. I think it will be available in about 2 years. Is
Okay.
our ambition. Yeah.
So this is due to more tests that you have to run, more longer term tests then, Professor?
Yeah, so we make this a small strip of plastic packaging, right? So in order to make it commercially available, then we have to make a bigger bag. Then the bigger bag we need a bigger machine,
Yeah.
and then we have to test it more thoroughly whether it's exactly how many days and what kind of conditions it can do its job in, right? So like you're asking whether it can do it for the soup, maybe not for this kind, but it can do it for the vegetables, for the
Right.
fruits, and so on. Yeah.
Okay, so Professor, good luck with that because we're certainly looking forward to it, and you're certainly well on your way, it sounds like. So good luck with the rest of the journey, and we hope to see it on the market really soon.
All right. Thank you so much.
Thank you, Professor. Have a lovely day.
Take care, Professor.
Bye.
And you too. Nice program.
Yeah,
Bye-bye.
thank you. Oh, she's so nice.